Hi everybody, welcome to We All Makers. Today, we're diving into the fascinating world of ball bearings. Ever wondered how these essential components in machinery are made? If you're curious about industrial manufacturing and engineering marvels, this video is for you. Be the first to discover. Subscribe to We All Makers today. History of ball bearings. Ball bearings have a rich history dating back to ancient Roman times, where wooden balls were used to reduce friction in machines. The modern ball bearing, however, evolved in the late 19th century, with significant contributions from engineers like Philip Vaughan and Henry Timken. These innovations led to the creation of the durable, efficient ball bearings we rely on today in countless applications, from bicycles and cars to complex industrial machinery. How are modern ball bearings made? Material selection. The process begins with the selection of high-quality steel. The most common type is chrome steel, known for its hardness and resistance to wear. The steel arrives at the factory in large, cylindrical bars, ready to be transformed into precision ball bearings. Cutting the steel. The first step is cutting the steel bars into small, cylindrical pieces called slugs. This is done using high-speed cutting machines that ensure each slug is the same size. These slugs will eventually become the inner and outer rings of the ball bearing. Forming the rings. The slugs are then heated to a high temperature in a furnace, making them malleable. They are then placed in a series of dies and pressed into the rough shape of the inner and outer rings. This process, called forging, gives the rings their basic structure. The heated steel is shaped under immense pressure to form the initial ring shapes, which are then trimmed to remove excess material and ensure smooth edges. Machining. After forging, the rings are machined to their final dimensions. This involves several steps. Turning. The rough rings are placed on a lathe and turned to the correct outer diameter. Precision lathes ensure the outer surface of the ring is perfectly smooth and round. Boring. The inner diameter is bored out to precise specifications using a boring machine, which ensures the inner surface is also smooth and accurately sized. Grooving. A groove is machined into the inner and outer rings to house the ball bearings. This groove must be perfectly sized to ensure the balls fit snugly and rotate smoothly. Heat treatment. Once machined, the rings undergo heat treatment to harden the steel. They are heated to a specific temperature and then rapidly cooled. This process, called quenching, increases the hardness and durability of the rings. The rings are then tempered to remove any brittleness introduced during quenching, ensuring they have the right balance of hardness and toughness. Grinding and polishing. The hardened rings are then ground and polished to achieve a smooth, precise finish. Grinding removes any remaining imperfections and ensures the rings are perfectly round. The grinding process involves multiple stages, starting with coarse abrasives and progressing to finer ones. The final polish is done using a special compound to give the rings their distinctive gleam and to reduce friction during operation. Assembly. Once all the components are ready, it's time for assembly. The inner and outer rings are placed in a special jig, and the balls are inserted into the groove between them. A cage is added to keep the balls evenly spaced and to prevent them from touching each other. The cage is typically made of a lightweight, durable material such as plastic or brass. The assembled bearing is then checked for smooth operation and any defects. Quality control. Each ball bearing undergoes rigorous quality control checks. This includes measuring the dimensions, checking the surface finish, and testing the bearing for smoothness and noise. Advanced techniques such as ultrasonic testing may be used to detect any hidden flaws. Any bearings that don't meet the strict standards are rejected and recycled. Additionally, the bearings are subjected to performance tests, including load tests and rotational speed tests, to ensure they can handle the demands of their intended applications. Packaging. Finally, the completed ball bearings are cleaned, lubricated, and packaged. They are sealed in protective packaging to prevent contamination and damage during transport. The packaging process is automated, with machines precisely wrapping and sealing each bearing to ensure it remains in pristine condition during transport. Each package includes information about the bearing specifications and instructions for use. Thanks for exploring the ball bearing production process with us. If you're amazed by the blend of technology and craftsmanship we've showcased, like, share, and comment your thoughts below. Don't forget to subscribe to We All Makers for more interesting journeys into the world of manufacturing and industry.